Okay, so we've got this example. We've got 280 students either travel by train or tram or both to get to school. 150 of those students travel by train and 60 travel by both. And we want to show all this information in one Venn diagram. The first thing that we can note is that the entire set is 280. Now, if we remember, this N notation tells us that the number of elements in the entire set is 280 because we have 280 students. We can also say that the number of students who traveled by train is 150 because we've got that here, 150 travel by train. So let's just start drawing the Venn diagram and see what other pieces of information we can work out. Okay, we'll draw our two circles. We've got one that is by train and one that is by tram. Now we know that the total number of students that travel by train is 150. And this key piece of information here saying that 60 students travel by both, straight away, I haven't left much room there, but we can see that 60 need to have traveled by both. So if the entire circle for train has to add up to 160, then in this section needs to be the difference. So you can imagine that 150 travel by train, you take away 60 because 60 is in the both section and we're left with 90. So we know 90 must only travel by train. We know that these three sections need to add up to the total amount. So the amount of students that only travel by tram will be the total amount, 280, minus our 60 minus our 90. I mean, really, we could have probably just written minus 150. But that turns out to be 130. So that's how we draw that Venn diagram. Hence, using the Venn diagram that we just created, we want to find the number of students who travelled by tram only. Well, we can see that travelling by tram only is the students in this entire circle. So it's this intersection section 60 plus the 130. And it equals 190 students. The way to write this using set notation is N tram, so the number of students who travelled by tram. We now want to look at the students who travelled by train but did not travel by tram. So we can see here, if we look at our train circle, if we want to include students who travelled by train but not by tram, we're not including this intersection. So we're just looking at this number here. So it's going to be 90 of those students. The way to write this in set notation, so we've got the number of the people who travelled by train, and it's the intersection with the people who did not travel by tram. So remember, I've got this tram, I put that in brackets so you can see with our apostrophe there, which is the complement. So that's saying train intersection with not tram. So you want to think about it. You're taking train, which is the entire circle, and you're finding the intersection with everything that is not tram, which leaves you with just this bit, not including that. And finally, we want to find the number of students who travelled using only one of the modes of transport. So essentially, we're just excluding the students who travelled by both. So the ones who only travelled by train plus the students who only travelled by tram, and that equals 220. Now, writing this in set notation is a little bit convoluted, but it's important to know what it looks like. So we've got, similar to what we've got up here, we've got the number of the people who travelled by train intersection with the people who did not travel by tram. That's our 90. And we want to add that to the number of people who travelled by tram with the intersection who did not travel by train. Now that does look a bit confusing because tram and train are very similar. You can imagine if you're using A's and B's, it might look a little better. So let's see what that would look like. So if you're using A's and B's, it looks a little bit more friendly. The next question asks us to draw a Venn diagram to show three sets. We've got A, B, and C in a universal set E. We want to enter the numbers into the correct parts of the diagram using the following information, and that's the information we've got there. So I'm going to see if I can draw this quite large so we can see it. We've got the universal set being 50, and we've got A, B, and C. All right, so we've got our Venn diagram drawn. Now we want to enter all the numbers in using the information here. So let's just start from the start. It's a bit like a puzzle. We just need to work step by step. We've got the number of elements in A, so we're just considering A at the moment, intersection with B. So now we're considering this intersection between A and B, this little ellipse here. And it's also the intersection with C. So we're looking at the very center where all three of these sets intersect. And the value is 2. So we can slot a 2 straight in there. We've got the number of elements in A intersection with B is 7. So in this section here, where A and B intersect, there needs to be a total of 7. We've already got 2 here, which leaves 5 remaining in there. So we can see that where A intersects with B in here, we've got 5 plus 2, which is 7. We're going to use a similar trick for B intersecting with C. It's going to be 6. So we've got B and C. It's this section in here. So it needs to add to 6. We've already got 2. There's only 4 left to place. 2 plus 4 is 6. Same thing, A intersection with C is 8. So we're considering this section, already 2 in that section. We only need another 6 there. It also tells us that the total number of elements in A is 16. So we've already got, if we consider the entirety of A, there's already 5, 2, and 6. Those 3 numbers add up to 13. To get us up to 16, we only need another 3. For B, there needs to be a total of 20. So we've already got 5, 2, and 4. Adding those numbers up, we get 11. Up to 20, we need 9. And for C, there's a total of 19. We've already got 6, 2, and 4 in C. They add up to 12. To get up to 19, we need 7. And our final piece of information, which I've already written there, is the total number of elements in this universal set is 50. So we need to see if there's any elements that are not in A, B, or C. So if I take 50 and I subtract all these numbers, it might take you longer in your calculator, but I believe they sum up to 36, everything here. So that would be 14. So we end up with 14 on the outside. So if you were to add up each of these numbers, they should add to 50. Now, using this Venn diagram, we want to find the number of elements that are in the set not A intersection with not C. So the way I like to do this is, I'm going to see if I can use my pen to sort of shade these sections. So let's look at everything that's not A. So obviously we can see that A is this circle here. So everything that's not A is everything on the outside of that circle. So that's everything that's not A. And maybe I'll just underline that green so we know. Now we want to find it with the intersection with everything that's not C. So I'll shade that with blue. So everything that is not C, which is this circle, I'll shade everything that is not C. It's all those numbers there. So it's getting a bit messy, but hopefully we can see that if we're finding the intersection where I've drawn blue and green together, they overlap in these two places. So everything that's not C overlaps with everything that's not A here and here. So the number of elements is 9 plus the 14, which is 23.